And just continuing this problem, we multiply both sides of the original equation by the integrating factor, e to the x, so that this is now exact. We proved it's exact by taking the y partial of this thing and the x partial of this thing, show that they're equal. So now we have to find the potential function. So this thing is our x derivative. So our fx is equal to y squared minus x e to the x. Now I'm going to take the antiderivative with respect to x. That's going to be my potential function, f of xy. Antiderivative with respect to x. Well, let's rewrite this as y squared e to the x minus x e to the x. Antiderivative with respect to x, this thing would just be y squared e to the x. I need a integration by parts for this. So I'm taking the integral, subtracting integral of x e to the x dx. Our u is going to be x. Our dv is going to be e to the x. The du is dx, and the v is going to be e to the x. Okay, so minus, and I want uv minus integral of v du. And this going off to the side, just to do the antiderivative with respect to x of this small part. Oops, I don't want to do all that. Okay, so I've got minus uv is going to be x dx minus integral of v du e to the x dx. So I've got opposite of x dx minus e to the x. So distributing the negative, we got minus x the uv was x e to the x, not x dx. That should be x e to the x, x e to the x, and then minus e to the x, distributing the negative, negative x e to the x plus e to the x. Okay, so over here I've got minus x e to the x plus e to the x, and then plus I've got my g of y, since I'm taking the antiderivative with respect to x. Now I'll take my y derivative. It's going to be 2y e to the x. That goes away, that goes away. So plus g prime of y, and then I'm going to set that equal to this thing, equal to 2y e to the x. Oh, isn't that nice? Those go away. So g prime of y is equal to 0. So g of y is equal to some constant. So that I'm going to plug up here for g of y. So my function f of xy is equal to y squared e to the x minus x e to the x plus e to the x plus k. And then I have my solution is going to be this thing equal to a constant. I'm going to call it C1. So when I subtract that over, my solution is y squared e to the x minus x e to the x plus e to the x, so e, is equal to our constant. And there is your family of equations that is a solution to our differential equation.